Thanks, John, for giving me an introduction there. I should probably just let people know we didn't talk about titles or anything, but I'm the Senior Director of Medical and Life Science Industry Strategy for Siemens. So my role with the company is to develop and help both us internally and also customers understand how to use these tools in the accomplishment of their medical device design control. So that's my role at Siemens. My background is I come from a operations and design background. I used to be a chief operating officer for a medical device firm here in Colorado. So just to give you a sense of my background, and I guess what we should probably do here is talk initially about where we're going to go with this design today or with this discussion. Our first graphic here to talk about the direction of not only this webinar, but the webinar series as we're going to do it is essentially a life cycle diagram that we have that I'm going to show you to discuss really how we're going to progress here. So the first webinar is going to be, and that's this one, is going to be a discussion really about how we source requirements and data into our design input model. And we'll talk quite a little bit about modeling. We'll talk about standards documents. We'll discuss really design controls in general, user needs and how they integrate with the design inputs, work item creation and linking. And of course, we're going to talk about all the different sourcing types. So we're going to have a little bit of a discussion about modeling and how modeling plugs into the design control, how we source in company standard operating procedures, standards, and then of course document traceability and how we can establish our document traceability into these different artifacts that we're going to develop as part of the design inputs. So once that's completed, we'll have a second webinar, and the second webinar is going to take our start at design inputs and then paste risk management into the discussion. So we're going to show both how the risk management is integrated into the design inputs and how we can do that at a digital level. And then we're going to go through a series of examples on how we can make design changes, how that pushes back to the risk management and integrates with the design inputs. So a rather extensive, much deeper dive on doing risk management as part of a digital file like this. Then finally, in webinar 3, we're going to talk about how we integrate testing into all this. So how do we develop test protocols? How do we execute those tests, do test runs, and manage the whole verification and validation cycle? And maybe just a little bit of discussion about how that can then be rolled up into regulatory submissions and how we can then integrate post-market surveillance into the whole data model. So that should give you a pretty good sense of the webinar series and what the different parts are going to be. And I just wanted to, this is just my agenda for today. I already talked about that. And this is my contact information. If you have any questions that I could answer from a logistics standpoint or how we construct these models, I'd be happy to offer any feedback that might be valuable to you. So this is just my contact information if you want to get a hold of me. Okay, so hopefully that's long enough to be able to write it down if you need it. Okay, so let's get out of this. Let's talk about the tool. So this is Polarian. And Polarian is a thin client application. Pretty much use any browser that's available on the market today. My preference is Firefox. So I have the best results, I think, out of Firefox, but it really doesn't matter which platform you use when you access the tool. So let's go ahead and talk about a few things here. The first thing is, what is the tool? And so Polarian as a tool, just at its base, is a system where we take logical ideas, or maybe a better way of saying it is logical artifacts. We draw a box around those logical artifacts and we interrelate them with relationship logic. And functionally inside the tool, we are most often operating out of what is a rich client interface, and that rich client interface allows us to author the documents in the form of a document and then tag each component in the document as to what it is, which type of logical artifact it is. And so we go ahead and take those artifacts. Let's just quit the Skype because that is confusing. And so we draw a box around those logical artifacts and we interrelate them with relationship logic. And so really at the base, we're identifying what the logical artifacts are, their relationship with other logical artifacts, and then we construct the design control in the context of documents. And so each of these logical ideas are tagged inside of documents, and then we're going to interrelate them. And I'll show you how to do that as we move along. So this is a comprehensive traceability table, and it represents what we have in this particular template as far as logic is concerned. So what are the work item types and how do they interrelate with one another? And of course, you're going to recognize all these concepts because this template was developed specifically for medical device. So our vernacular and the terms that we use for regulatory submissions are all captured and encompassed inside this template. And so I'm just going to go ahead and walk around some of these artifacts, talk about how they relate to one another so you can get a sense of how this logical model is constructed. So I'm going to start with the blue pieces here. We have user needs and inputs. Oops, I got to quit doing that. I'm forwarding my website here, or the web page. So we have user needs that are refined by design inputs. And just to be clear, design inputs is one of the places where companies do a lot of customization. And the reason, customization is the wrong word, it's really a configuration. I can show you later what the administrative panel for doing this is. It's not a matter of customizing the code, it's just a matter of creating new artifacts and showing how they interrelate with one another. But these design inputs really are related not only to the company and how the company conducts their business, but also very much so, they're different from project to project, design project to design project. So just to give you an example, we have system requirements and design requirements just shown here, but very often what we end up with is a much more complex model. So that model can be as simple as what I was just showing on this other page, where we have even just one design input, we just have one requirement type, or it can be very much more complicated than that. And so in this model, what we're talking about is a fully blown out set of a V model. So running from user needs to, sometimes people will break their design down by subassemblies, but sometimes they break them down by feature function. In addition to that, we have system of systems requirements, we have multi-domain system requirements, we have single domain system requirements, and then oftentimes we'll break those single system domain requirements into, in the case of software, it's items and units, or subsystems and design requirements for some of the other disciplines. So if we're doing a multifunctional, maybe a generator for a surgical instrument or a ultrasonic piece of equipment or an MRI, something like this, where we not only do we have single domain sets of breakdown or design decompositions, but in addition to that, we have system, multi-domain system across all the different domains, and then system of systems. So this is very common, for example, in automotive, where you're going to have a vehicle is going to have many computers, and those computers all have to interrelate with one another. And we have requirements at the system of systems level, not just multi-domain. So just to give you a sense that this design inputs question that we're talking about is very much customizable. It's very different from product to product and company to company, and is the subject of quite a bit of change as the new projects are created and you end up with different types of products you're trying to develop. But in any case, the user needs are refined by those design inputs, or design decomposition occurs at that design input level. And then we satisfy those design inputs with design outputs. And our design output is a representation of a variety of things, but mostly what it is the device master record. So we're going to have whatever is required to satisfy those design inputs. Those outputs that satisfy will be tagged and can be referenced to systems outside of our system. So as an example, when we use Teamcenter as the PLM system, this output work item just maintains the traceability inside of Polarian, and then it points to the artifact in the PLM system. So that's a very common way to do it. We have customers that are using both Teamcenter and a variety of other PLM tools to carry and hold those artifacts, and then they just use it in the design outputs for traceability. Okay, so just to continue around the loop, we then have manufacturing requirements which satisfy the outputs, and that completes our mitigation plan, which is user needs, a variety of different design inputs. By the way, one of those design inputs is typically labeling, and manufacturing requirements represents our product realization. And so therefore we have the three different methods of doing mitigation to hazardous situations. And this becomes our mitigation plan. And so at the top level, then we have risk records, harms, and hazardous situations. The hazardous situations are linked in the same way that user needs are linked with the refinement relationship to inputs. We have user needs and design inputs and manufacturing requirements that are mitigations to hazardous situations. And so we'll get into this in the next session in more detail. And one of the really cool things is we'll have a modeling example of this as well. We'll link modeling into it, but risk records, harms, and hazardous situations represent our analysis of the risk, and then the mitigations become direct controls of the occurrence of the hazardous situation. And that the great thing about that is when the VMV then is completed and we've finished our testing, we by definition have completed our mitigation of our hazardous situations as well. So just to give you a kind of a sense of the overall loop. Now today's subject and the thing we're going to talk about more is really product sources. So what is it exactly that we're trying to source into our design control? And these product sources are typically ISO documents, a lot of times they're modeling, internal SOPs, a bunch of different documentation and processes that are going to end up sourcing our requirements into the design control. So that's going to be the main subject that we're talking about, and that's what this artifact represents. So to begin with here, what we're going to start with is just to give you a sense of the tool. So in Polarion, we have spaces. So just from a hierarchical standpoint, how is this constructed? Polarion has a hierarchical construction. Starts at the repository level. Under repositories, we have groups of projects. Under groups of projects, we have the individual project themselves. Under the project, we have spaces. Under spaces, we have documents, and inside of documents, we typically is where the work items reside. And so that's kind of the overall hierarchy. So in this project, which we're going to call medical device template, we have a variety of spaces. These spaces contain a group of things that we know are required for different aspects of doing medical device development work. So I have SOPs, inputs, outputs, risk management file, testing. And those are the main categories of the things that we're going to need to group and do our submission. At the top here, we have US regulatory and EU regulatory, and we'll talk about those more in a subsequent webinar. But the idea being when we finish our design control and we put all these artifacts together, we can just copy them into our submission and have our submission be controlled along with all the other design control elements. So that's going to be a fun thing to talk about here in the future. Okay, so we got inputs. We're going to start with inputs. We have a product requirements document. This is the rich text interface I was talking about, and this is very much going to remind you a lot of the Google Docs rich text interface, with the exception of we have a widget on here that does something special. And so we're going to, let's just pick a spot here, wherever, and we're going to author a couple requirements. So we're going to say this is a requirement, if I could type. And we're going to say this is a user need. So when we author these work items, we're going to do them in the rich text interface the same way you would if you're just typing in a document. So you can have images, you can have tables, really anything that you can get into a document can be in the body of the work item that we're creating. So what we're going to do is then we're going to tag it, we're going to select it, and we're going to say this is what we want to call a user need. So that's what this thing is that we've just authored. And then we're going to do the same thing for a requirement. So we're going to call that a system requirement. So we have these two different things that have been authored, and what happens when we first tag them is it's going to give them a temporary number. So that's why the 1, 2, 3. We'll just go up sequentially until such time as you save the document, And when you save the document, it's going to push those down to those artifacts down to Subversion, and it's going to give them an immutable number. So that number now is the permanent marking number for this particular work item. Not work item type, but work item. So the first 4 letters or numbers, it's alphanumeric, it can be numbers or letters, is the number or the name for the project, the tag for the project. The second set of numbers is a sequential number, and that sequential number is assigned whenever the next work item is created in the project. And so you can see we did 2 of them here, so we have a 6016 and a 6017. Okay, so now this has been pushed down to Subversion, and it's a permanent part of the record. So what we also want to do, though, when we have these work items, is we want to be able to link these work items together. And we want to be able to say we have a relationship between these 2 particular things. So the way that's accomplished, and I would say 90% of the linking that I do is done this way, is you click on the link icon and it's going to bring up this interface. The purpose of the interface is to allow you to select what type of relationship I want to attach this work item to another work item. And it doesn't know what work item type you're going to be attaching to, so it gives you all the different possibilities. And in this case, we're going to be doing a refinement because the input is a refinement of the user need. And we're going to click on the chain link icon for the user need, and now when we get this blue interface, it says those 2 have been linked together. Okay, so we save the document, and now that linking relationship is established. And it's important to understand that as a web application, the product doesn't care whether it's we have 5 documents opened in different tabs. I could just as easily have linked from the work item in this document to the work item in the product requirements document as have authored them both in the same document. The system doesn't care. And in addition to that, it's not just document to document, but I could also make these establish these relationships between projects anywhere really in the repository. So there's a lot of flexibility in how these linking relationships can be made. So on the right over here, what we have is a panel, and the panel gives you a variety of different options. But I'm just going to talk about this one real quick, and then we're going to get off of this and start talking specifically about sourcing. So work item properties is a nice panel that we have, and the purpose of it is to allow us to see whatever type of metadata that is associated with this work item type. Allows us to display that on the right-hand side. And you can change this, this will show up differently for different work item types. If you want to customize that, you can, and it's going to show you a whole bunch of artifacts based on what you've defined for that work item type. Kind of standard for all the work items, if you don't change it, is this set here. And what it tells you is the ID of the work item, the type, so what work item type is this? Status is a question of workflow. So each work item has a workflow that you can push it through for approval and for dissemination through the design control file. And in this case, it just has the standard set, but that tells you what the current status is. So we just created this work item and it's in the draft stage, which is makes sense. And then the final one is links. And what this is all the linking relationships that this particular work item has with other particular work items. And so we can see that the user need has a refinement relationship between that and the requirement below. And this is the relationship we just established. And so as we build out the file, when we create a work item type, doesn't matter what the work item is, and when we establish a linking relationship between those work item types, wherever it's done, whatever the types are, this is probably 80 to 90% of the linking relationships you're going to create are going to be done in this way. And so once the data model then is constructed, we can programmatically and through the reporting, we can just follow from a work item type all the way through the progression for all the linking relationships that it has in the file. And that is going to be a really powerful thing for us in the future as we develop the file and we start using it to determine whether we have an impact to a design if we establish a problem through risk management. Okay, so that's all I'm going to talk about today from the standpoint of how do we create work items, just to get you oriented to know what a work item is and sort of logically how they're interconnected. And that'll help our discussion as we go through sourcing relationships. Okay, so let's talk about a few things here. We have the sourcing relationships now. So before, what I was talking about, this is sort of a simplified version. I said product sources are going to be linked to the different artifacts in the design control. So let's talk a little bit about what that really means. What do I mean when I say I'm going to be linking in source documents? Well, let's start with what is a source document. So we have a whole variety of different things that when we start a project like this, the quality department, risk management, maybe marketing, a whole bunch of people come to us and say, here's our requirements, here's what we want out of this product when it's completed. And it's not just marketing, it's not just sort of ISO documents and quality, it's also, we have legal requirements. And so what we typically do in this to manage this is we break this down into two different work item types. And so we're going to call the work item types statutory source and product source. And the reason for this abstraction is many of the sources that we deal with when we're talking about design control are legal. And so the CFRs, I always want to say QSRs, it's funny. The CFRs, MDD, some of like the 1345 and 14971, a bunch of these sort of top level standards impact the company and impact products, but they do it indirectly. And so what we typically do with, just as a 14971 for risk management as an example, is the company will pre-process those requirements into a company SOP, and then the company SOP is how we operate under that standard. And so the company SOP impacts the product directly, but a lot of these other standards don't. And so we need a level of abstraction to avoid having the design impacted by two levels of requirements. So I don't want to have to break down 14971 and break down the company SOP and trace those requirements into the design control. So when we have this sort of pre-processing abstraction, we break them into different types of work items so that we don't impact the product directly by all this chaff that's sort of outlying our SOP process. But in addition to SOPs, we have modeling. So model-based engineering is a topic that we've been talking about quite a bit over the last 5 to 10 years probably, but essentially what we're doing is we're using models of a variety of different kinds to determine what the requirements for the product should be. And then those requirements get driven by this model, and in some cases we can even validate the model and justify not having to repeat the testing if the modeling is correct. So the more we can push that sort of engineering expertise into the front end of the design, the better. And so one of our sources that we're going to have tracing into our design control is modeling of a variety of different kinds. And so it's just some examples. We have Enterprise Architect and not a Siemens tool, but Enterprise Architect and NoMagic are a couple examples of more systems levels tools that we're trying to integrate, but also Siemens has a whole variety of different modeling tools, both from a FEA standpoint and computational fluid dynamics. We have CD Adapco, and with the purchase of Mentor Graphics having closed today, we also are subject to a whole bunch of modeling tools on the electrical side. So modeling is a very comprehensive thing that we have to learn how to process into the design control. Just to give you an example of that, when we go into the flowchart that I had shown you before, this flowchart breaks down all the different requirements, but in addition to that, the different modeling sourcing occurs at the level of the domain. And so if we have a part, a mechanical design part as an example, what we would do is we'd source the SimCenter modeling directly into the modeling, the mechanical design requirement. And that's because that modeling is impacting that part directly. But we might, at a system of systems level, we might be using Enterprise Architect or NoMagic or even just a flowcharting program to model what we expect out of that systems level performance, so we understand why we're talking about the interface requirement or the architecture requirements as we've defined them in the requirements at that systems level. So couple different things that we're going to have to learn how to do is not only architecturally where should we, or what types of things should we model in, but when we do create a sourcing relationship, we need to plug it into the appropriate artifacts in the design control. And that's the subject that is probably a subject for an entire webinar in and of itself. So, okay, we have modeling, so that's a big piece. Next piece probably is voice of the customer. Oftentimes marketing is going to impact the design with particular requirements. Company knowledge databases. A lot of times we have design standards, we have a snap fit, we do snap fits in a certain way, and this company will do our snap fits in this way, and we have documents that have to be complied with that represent those that company knowledge or that company history. And of course, in addition to that, we have a whole bunch of documents. We have ISO documents, we have EN ISO, we have IEC, we have FDA guidance, ASTM testing documents, all kinds of just a litany of different documents that will define standards on how we're going to do this development and testing process. So all these things need to be processed somehow. And one of the great ways to do this is in Polarion, what we do is we break down these documents into their components, and then we link them into the design control. So let's just talk about that a little bit. One example. So here's an example of a labeling requirements SOP. And so what this labeling requirements SOP does is it goes through and it just discusses how are we going to, what's the content of each of the labels. So this is just an example. The IFU shall include the following. And then we have the company logo name, the product name, the product generic name, product catalog number. Most of these are requirements from an ISO document. And so this SOP pre-processes that ISO document, and we've determined that these are the things that need to be in our IFU. Of course, these can and often are much more detailed. You might have standards on the company logo from the standpoint of how big that logo should be, Pantone colors. You might have all kinds of things that represent how that logo and name is going to be represented in your IFU so you can standardize it. But for the time being, just for our sake of our discussion here, we're just going to say it's the company logo and name has to be represented. Well, so what we do then is we break these all down. So you can see in each one of these cases, I've tagged it. So this is a product source, this is a product source, and what that allows us to do then, when we go over to the product requirements document, is we're going to satisfy each one of these requirements with a requirement in the design control. So in the product requirements document then, we're going to have a product requirements document. What am I talking about? So not the product requirements document, but the IFU requirements document. What is what's the problem here? I've got the wrong content. Okay, so the IFU, we're going to have, a bunch of different things, like the language will include the following translated information. So the company IFU will include the ISO standard manufacturing symbol. So this is the requirement we had in the labeling document, in the labeling SOP. Well, so here is our linking relationship. We have this labeling requirement. When we go over to the work item properties panel, what we're going to see is it's sourced by the PR1 5813, which is one of the source standards we have in the other document. Now, the really cool thing about this is when we're finished linking all these together, what we can do is we can create a traceability chart at the end of the document. And what that traceability chart is going to show is where each one of these product sources have been, where they've been satisfied in the design control. And so now we have a traceability running from the design source to the design control. And then when the testing is completed, it's going to show what is the test that we did to prove that that company name, address, and telephone number was actually included in the IFU. So you can imagine that this is a very, very powerful thing for us to do. What we're going to end up with is the ability to go through each one of these documents, break them down on the basis of their content, and then show in the design control where they're satisfied and where they're satisfied from a requirement standpoint and what test was done to verify that that content actually exists inside the labeling. So that's really great. Okay, we've identified what it is that the content should be, but that's just sort of part of the equation. Now we want to actually do a test. Well, one of the really great things about Polarion is this is just one of the sort of unique uses of the tool that I do. When I'm authoring test protocols, I kind of like to branch the IFU requirements document. And so here we have a IFU requirements document, and if you create a branch of that document, what it allows you to do is create a copy of the document with all these artifacts in it copied. And the really great thing about that is as we're defining then the test cases, we're going to see that the test cases, I can author them directly under the requirement because these are actually the requirements that are contained in the IFU requirements document. So if I update the requirements document, all my artifacts that I'm authoring my test cases from would also update. You can see that in Polarion because Polarion, the way the graphical interface works is when we select on a work item and we get this solid bar on the left-hand side, what that means is that the home or the place where this work item is contained is the document that I'm in. If I select on it, however, and I see this dotted, these dots on the left-hand side, what that means is this is a copy of that particular, and a copy is the wrong word. I'm using the wrong vernacular internally, but if it's a copy of that particular work item, we have this dotted interface on the left side. And what that means is the home, the place where this work item is contained, is a different document. And if you wanted to find it, you would open the item and you track into that document directly. So, but the really neat thing about this, just a little clue here, the neat thing about the authoring it in this way is I can author then the requirement or the test case with all the information for the requirement right on top of it. And I just kind of like that as a user interface. So when you complete this test protocol, what we're going to end up with is a list of test cases that tie out every one of the requirements that are in the IFU requirements document. And as that gets completed, we're going to actually do a test run. And you can see, let's just open up one of these work items. And what we're going to see here is that the work item has a certain amount of information in it. And as this is sort of a special work item type, and what it allows you to do is author test steps with expected results, and then execute those test steps against the product or the IFU that you've now authored and you're trying to test. So you'd start the test case, we'd put in the result of each step, we'd click on the step verdict that we have, and then an overall test case verdict. Did it pass or did it fail? One of the interesting things I think about doing test cases is there's a certain level of abstraction that we're allowed to do. And the way this works is we have the test cases that are authored, and oftentimes we author those in a test specification. So I'm going to group up a bunch of test cases into a test specification or a test protocol, and then we're going to do test runs on that. And typically in software, we have a variety of different kinds of tests. We'll do smoke tests to get a sense of whether we believe the overall test is going to pass, or we can do full testing. A lot of times in mechanical, we'll do a test run that represents exactly what the test protocol is. So this test run would be a test results, and in other words, we do the test run. All of the test cases would be executed in the context of a test run, and all of those would be then displayed in the test result. But it does allow you, the system, because we have this abstraction between test runs and test cases, allows you to do a variety of different quick tests. And sometimes in biocompatibility, as an example, we'll do a quick test. We might have the whole protocol set up, but we might do a cytotox test just to get a 80-90% confidence that we're going to make it through the biocompatibility before we run the entire test. So that's same type of thing in software, same type of thing in electrical testing. It allows us to break the testing down into a more granular level if we choose to. All right, so we have these test cases, and once we execute the test runs, we're going to end up with a test report. And so one of the really neat things about the process is all the test data is now contained in the system. So the test runs, the test cases, and the test protocol are all well understood and tagged as to what they are. What that allows us to do then is author our test reports automatically. So all we're really doing here is we're asking, let's go to document properties, and we're saying we want to take a look in this at the test run IFU conformance, right? And so everything that's contained in the test run IFU conformance will be displayed. And so here are all the results for all the different tests that have ever been run. And this is an incredible savings of time, where you don't actually have to author what the results are, and all that's automatic. And then the only thing we really need to discuss is what's the implication. We had this test result. Is it a good result? Is it a bad result? And close it out and export it for use, or run it through its life cycle for approval. So that's really the discussion that I wanted to go through to kind of give you a sense of all these different documents. How is it that we identify what the requirements of this sourcing document are, how we establish a test protocol, how we then execute the test cases and then show it in a test report. What is that system? And of course, once we're done with that, we'll be able to run traceability at the document level, and that's going to show us how the entire thing ties out into the design control. One of the things that you might ask yourself is, well, why do we bother going to all this effort? Well, there's a variety of reasons. One of them is oftentimes these standards step on one another. So just as an example, I think it's dash 8 of the IEC 60601 document. That document has usability as included in it. But in addition to that, we have the overall medical device usability standard. I don't even remember what the number of that document is, but those two documents represent the same thing, really. They're talking about the usability of the device. Well, what if we have two requirements and they contradict each other, or those two requirements are slightly different? Somehow we need to be able to process our design control, given the fact that we have 4 or 5 sources of a requirement, and decide what is it we're going to do for this project. And what is our justification for that? So I'm authoring the requirement out of 4 source documents. Maybe I'm going to lean a little bit more heavily on number 2, and we're going to ignore number 4 altogether. Well, that's fine, but we need to have the justification captured inside the design controls so that when we come back later and somebody says, I can't believe they made that they're doing this the way they're doing it, this document number 4 very clearly outlines that they can't do it that way. Well, when they get into the design control, they would see all 4 sources and then the justification for why it was there. So it really allows us not only to process and properly understand our design as we're creating it, but also when we come back and make changes later, we don't lose all that historical information. And this is really great from the standpoint of saying, okay, we've completed a generator. We're going to go back and do a revision of that generator. Well, I want to take all that information that I did in my last generator. I want to create a new project and pull all the branch information, all that information for the original design, and reuse it all. But it's not just the requirements. It's the requirements. It's the construction of the test protocols. It's why did we make all the decisions we made? What are the source documents? We want all that information to come in. So now it's not a question of recreation of all that. It's really a question of, is it still pertinent? So we would just walk through the design and say, has this requirement changed or not? And if the answer is no, then we not only have the sourcing relationships, but also the user needs, the design controls, the test cases, both verification and validation, and an initial understanding of what our performance was in the last product. So it's really powerful from the standpoint of the original creation of the file, but it's incredibly powerful from the standpoint of as we progress forward doing new designs and trying to categorize those designs as we go. Okay, so that is pretty much what I had to show you today. We have the discussion about design controls, but also the overall design traceability, and that design traceability and how it links in to the creation and the standards that we have. So next time, again, we're going to be talking about risk management and get into the details, the nitty-gritty details of how to create and how to link in risk management. And then, of course, the last one, we're going to have a much deeper dive in testing. So if you had any questions on either one of those as we jump through, hopefully we're going to have a much more extensive discussion. And just as a promise for the next one, the risk discussion, we're going to actually link in MATLAB as a source and make a change and show how that change progresses around the risk system and then back to modeling. So that should be a lot of fun. Okay, so I guess that's it for today. Just if you have any questions, I got a couple questions as I was finishing up here. I thought maybe I would go ahead and address those. The first one is, how would you suggest we integrate our PLM system into this logical data model? Really great question, and we've tried to do this in a very standard way. Of course, Teamcenter, we have our own PLM product, and so internally we have a method for doing this. The way we do it is we do it at the output level, and so you can see our design control has user needs and design inputs, so we have system requirements, design requirements. All of that is contained directly inside of Polarion, but when we create a artifact or a pointer to hold that output place in the design control, so we can do traceability from the parts or the assembly instructions, those artifacts, we author those in different programs, and they're stored in the PLM system in Teamcenter. And so what this output work item ends up being is a proxy to pointing to where those artifacts exist in other systems. And you can imagine there's a lot of different authoring tools. With the purchase of Mentor, we have a variety of different electrical engineering authoring tools, both board layout and at the IC level. In addition to that, we have NX, which is an excellent tool for doing mechanical development work. Well, that authoring tool plugs directly into the PLM system, so all this is a proxy out to that PLM system. So regardless of whether we do it to our internal tools or to an external tool, I think this is a really nice way to do it because it provides a sort of a stopping ground and a logical place to stop doing design control and start doing the actual product management out in the field. Okay, so next question. When you were talking about integration of modeling, how would the modeling be integrated into the system? Yeah, and I think maybe this was asked just before I talked about it, but the best place I think to integrate modeling is at the requirement level. And so if you have 5 levels of decomposition of the design from system of systems all the way down to maybe mechanical design as an example, the best place to link the modeling into that data model is at the requirement level, so that the model represents what you're doing at that level of the design decomposition. I think that's probably the best way to do it. The last one is, do you have another project for storage? Oh, storage of the standards documents, or is that all contained inside the product project? Lots of different ways to do this. I've seen a couple that you might find interesting. One, if you don't have too many products, it's pretty easy to create a project of a QMS project where you put all the different documents that you need to be compliant with, and then just link the work items in those documents directly to the products that you have in the different project folders. The problem with that is, as you start getting into maybe 200 or 300 projects, let's say once you get north of about 50 different products, what you're going to find is it becomes a little cumbersome to go to a work item and have 30 things linked to it in different projects. And so once we get to that level, I think, and if you're planning on implementing the tool on a great variety of different products, I think it makes probably more sense to have a QMS project where you author all these documents, but then when we create a new project, we copy those ISO standards or the different standards into the project itself, and then we use reporting tools instead of traceability to find where those documents are and determine what the relationships are to the product itself. So there's a variety of different ways to sort of architect that. And I guess I would suggest that we sit down and talk about it a little bit to see what the most appropriate way, where you'd have the least impact to your business and the best traceability going forward. Okay, so that's it for the day. I guess we're gonna go ahead and call it a day. Appreciate you taking the time to discuss this with me or listen to the presentation. If you have any questions, please feel free to give me a call or shoot me an email. Look forward to the next session. Thanks a lot.